Welcome back, students. So this is my fourth part of laws of exponent. In this video, we will discuss about the standard form or scientific notation which are used in exponents. Okay, so I will give you an idea about the scientific notation and the standard form of numbers, why we are using it and how to use it. This is the thing that we are going to learn in this video. Okay, so let's start. Look at the following numbers and their equivalent notation. So you can see that 42,300, it is equivalent to 4.23 into 10 to the power 4. Similarly, 0.0000004245 equals to 2.45 into 10 to the power minus 7. One more, 124 can be written as 1.24 into 10 to the power 2. So all the above numbers are written as the product of the decimal number and an exponent of 10. This notation of expressing numbers is known as standard form or scientific notation, right? So all these are known as the scientific notation, or standard form of writing the numbers, right? Now how to write this one, and before that let's understand why there is a need of writing the numbers in the scientific notation. So for explaining this one, I will give you one example. Consider the speed of light. In physics you might have read that speed of light is something equals to 30,000,000 meter per second. So you can see that the speed of light is a huge number, right? So whenever we need to write the speed of light, we have to write this one many times. It may be happen that we have to use the speed of light many times. So it becomes very difficult for us to write down such a huge number. So there is another notation through which we can represent the speed of light or any big number. So that is known as the scientific notation. So the scientific notation is very useful in expressing very large or very small numbers, right? So just suppose if I am saying that length of a bacteria, if I am taking, so you know that bacteria is a microorganism and its length is very small. So you can say that just suppose its length is 0.0000007 centimeters, right? So you can see that the length of bacteria is very small. So again, whenever if we have to write this one, so it is very difficult to write this number again and again in this way. So for the convenience of writing any number, any big number or a small number, we are using the scientific notation, right? Now let's understand how we can convert a number into a scientific notation. That means any number can be converted into scientific notation. So let's understand how we can do that one. So let me make some space. Okay, so let's start. Okay, so let me take the example of speed of light. So we know that it is 30, 000000. For a very big number, how to convert it into the standard form or the scientific notation. So you know that any number can be written with the decimal. Just suppose I am having 25. So how I can represent this one in decimal notation? It can be written as 25.0, right? Or any number, just suppose if I am writing 3001. This can also be written in the form of decimal as 3001.0. That means point is there, but since after the point only zeros are there, so we are not writing it. So here also in the same way, point is there, but we are not writing it because after the decimal nothing is there, only zeros can be written, right? So we have to move this decimal point towards the first non-negative number. So here, sorry, non-zero number. So here you can see that the first non-zero number is 3. So after this we have to put the decimal. So my decimal points from here to here, it will travel. So this can be written as 3 point, and after the point all are zeros, so I will write only 1 0. So I have shifted my decimal from here towards the 3. But how many places it has traveled? So let's see. Just suppose it has traveled 1, 2, 3, 4, 5, 6, 7 and 8. Because we are inserting the decimal here in between 3 and 0. So it has traveled 8 distances. So simply we can write into, or I can write into 10 to the power 8 meter per second. So in this way, we can convert a big number into the scientific notation. One more example we can see. Just suppose if I am taking a big number, let's say 425,170,000,21000. This is a big number and we have to convert this into the scientific notation, right? So what we can do is, we know that the decimal point is somewhere here, right? So we have to shift this decimal towards the first non-zero number. That means the decimal point will be shifted after the 4. So we will write 4.2517000021. After this to 1, you can see that all are zeros. So no need to write, because after the decimal we know that if after the decimal only zeros are there, then we can neglect that one. Okay, so into 10 to the power, what we will write? We have to see that the decimal point has traveled how many digits. So let's count. So you can see that from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And after the 12, it has got its place. So here we can write 10 to the power. So this is the scientific notation of such a big number. Now let's come to the scientific notation of small numbers. So let's take one small number. So I can take one example of a small number as 0.00000034. Right? The same thing we have to do it here also. We have to shift the decimal point towards the first non-zero number. So that means the decimal should come here after the 3. So this can be written as, we will neglect all these things. We will write the first non-zero number. So here we have written the first non-zero number, and after that the decimal will come. Yes, of course. And after that, whatever numbers are there, that we will write. So only after the decimal 4 is there, so we will write 4. Now after this we have to write into 10 to the power what? You see that the decimal point has shifted towards the right side, right? The decimal is shifting towards the right. So any decimal number, if it is shifting towards the right, the power of 10 will be -1, right? And here, since the decimal has shifted towards the left, so the power is always positive. Okay, that thing you have to keep it in mind. Whenever the decimal is moving towards the left, the power will be plus, and if the decimal is moving towards the right, the power will be negative. Now let's see how many places it has been shifted. So from here 1, 2, 3, 4, 5 and 6. So here the power of 10 will be 6. So this is the way to represent a very small number in the scientific notation. One more example for the convenience we can say, see. So let's see one more example. Just suppose if we are having um, 2, 3, 5 or yes, some number is something like that. Okay, so we have to write it in the scientific notation. So our first non-zero number is 2. So that means the decimal will shift after the 2. Here the decimal will come. So let's write down 2.35. So all the non-zero numbers we have written, and after that we have to write down the power of 10. Since the decimal is moving towards the right? So the power will be negative. So I have put the negative sign, but how many places it has been shifted? So let's see. 1, 2, 3. So only 3 places it has been shifted. So simply we can write down to the power minus 3. So this is how uh, we have to write it in the standard form, or you can say in a scientific notation. So that's all about this video. If you like the video, press the like button. Thank you for watching. Bye.